Hello and welcome to another guest tutorial on the coding train. Yes, this is the coding train. What you are about to watch is an edited version of a live stream from a couple weeks ago about hardware and JavaScript. And I was near the hardware and it didn't light on fire, which is kind of blowing my mind right now. Now, this video will not feature me. It features a wonderful guest that came here to do a live stream in the studio. Her name is Suz Hinton, aka noopkat. And yes, it's pronounced noopkat, even though for the last many years I've just been saying noopkat. Noopkat, she does live streams every Sunday on her own Twitch channel. Check this video's description for a link to that Twitch channel. Highly encourage that you go over there and subscribe. And what you're going to see actually is a version of my, of the 10 print coding challenge, but on a hardware little screen, OLED screen thing with JavaScript controlling it and an Arduino. It's crazy. It's amazing. You got to watch this video. Okay, so thanks for tuning in. I got to stop talking because you're here to see noopkat. Goodbye.
Thank you, Dan, for having me. I'm so excited. I'm such a fangirl of the coding train, so I'm like really excited to be here. And also, so I do a lot of hardware stuff, so I wanted to sort of briefly intro myself on that. I work on a lot of open source JavaScript hardware, which I know for some of you, you might not typically associate JavaScript with hardware, but I promise that it's actually super fun to get started with it. And it's really, really quick to prototype with JavaScript hardware. So that's kind of its main attraction, but you can also just create your own kind of fully implemented, like real contraptions and still run JavaScript to control it. So I'm going to show you one way of controlling hardware with JavaScript today. We are going to be working with an Arduino, and it's an Arduino Uno, which is kind of the most common one that a lot of people get started with. And we're going to be driving this thing called an OLED screen, and I'm going to explain all this just to make sure that Dan's not super scared. Because Dan told me he's really afraid of hardware. And I'm really afraid of generative art because I feel like I'm not good at it. So I'm trying to combine the two together because Dan's really good at generative art. So somewhere in the middle, we're going to find like a nice happy place where we're both learning something. So hopefully it's going to go well. So yeah, thanks so much for joining us. I'm so excited. I'm normally streaming on a Sunday. And yeah, I'm streaming on a Friday, which is blowing my mind. So yeah. So I am going to just take you through a couple of the tools that we're going to be using today. Just forgive me, this is not my computer, so we had some sort of last minute shenanigans, but I think it's going to be okay. So I'm going to be using johhny-five, which is kind of the beloved hardware JavaScript framework. It has been designed to be like the jQuery of hardware. So if you've ever used jQuery before, then you know that it's a really nice API. It's super accessible to get started with it. So johhny-five was designed by one of the contributors to jQuery, Rick Waldron, and he's done a fantastic job. And there's been a lot of contributors ever since. I think there's at least 70-something contributors now, and that was when I checked a couple of years ago, so it's probably even bigger now. So we're going to be using this with our Arduino. So if you wanted to follow along with some of the beginning code examples that we'll be using today, you can go to johhny-five.io. It's kind of like the short circuit robot character, so I really like that it's named after that. And we're also going to be making use of a module that I wrote a little while ago, about 3 or 4 years ago, and it's called OLED.js. And OLED is the type of screen that this is. It's an OLED screen, just meaning that the little pixels that are showing up on the screen are actually driven by OLEDs, which is like a type of LED. And so I wrote this module to be compatible with johhny-five so that you can just start really easily drawing to the screen without having to know a lot of the stuff that's going on underneath. So I'll cover a little bit more on that when we actually get started, but we're also going to be using that as well. So I wanted to give a shout out to my friend Tim Holman because he's actually the one that finally got me playing with generative art super recently. We hung out at JSConf AU in Australia, and he gave this awesome talk about generative art and how you just need a few simple things in a toolkit to get started with, and it's the first time I've felt like not afraid to do it. So I just wanted to, so you should check out Tim Holman's website. It's tholman.com. And yeah, he does really, really, really hilariously funny stuff on the internet, so you should absolutely check him out. So I wanted to thank him for finally getting me started with it. So the generative art that we're going to create today is, well, at least on this website, it's called a pseudo maze. Is that what it's actually called, Dan?
Oh, maybe. It looks like the 10-print design.
Is that what it's called?
Is it that you just pick randomly like a left or right?
Yeah.
So it's not actually a maze.
Yes.
Yeah, no, that's exactly, I have a coding challenge that's exactly that pattern.
Yes.
And it's from the old Commodore 64.
Oh.
There's a one line of code, 10-print, go to 10, where you randomly pick a forward or back.
That makes sense. So
that's perfect. This is very good synergy.
So I noticed also that you did like a coding challenge on Floyd Steinberg.
Yes.
Yeah, so displaying like photos or just like high resolution images on these screens, it's very effective to use the Floyd Steinberg algorithm too. So this is me trying to get you less afraid of hardware because you're still using the exact same stuff on this. So if we have time, I don't think we will, but if we have time, I can also show like displaying pictures on this thing. But for today, we're actually just going to work with lines, which is super simple to do. And just to kind of like explore the concepts of generative art. So if you've already seen Dan's coding challenge, this is going to be pretty similar, but it's going to allow you to see how you then apply it to something like hardware, I guess. So I think it'll still be super interesting. So thanks for tuning in. Okay, so that's sort of a super quick crash course to stuff. I do actually have a folder right now that I've created. I did pre-install some stuff ahead of time just so that we don't have to sort of like sit around waiting for npm to install. But I will be doing this with Node.js today, which is a way of running JavaScript outside of the browser, which is really cool. So if you go to nodejs.org, just like that, you should be able to read up about it, but it's really, really cool. So that's kind of what johhny-five runs on top of. But recently I did get it working in the browser, but that's for another episode probably. Cool, so I have this folder here. I've installed johhny-five, I've installed OLED.js, just those two packages that I showed you before, and that's it. And then we have a code editor here. I didn't quite get Vim set up. I was on a mission to get Vim going because if you've seen my stream before, you all know that I use Vim. But so we're using Visual Studio Code instead, and then we're going to just keep crossing back and forth between iTerm and Visual Studio Code. So let me know if you can't read anything, and Dan will yell at me, and then we'll figure it out. Cool. So I do actually have the Arduino plugged in right now, as you should be able to see. So we're not actually going to plug anything into it yet. We just want to kind of establish a connection to it first, just to make sure that we can do our little hello world, and then we'll start plugging in this screen. So I sort of wanted to do a lot of this stuff from scratch, just so you can kind of see it from the beginning. So I've created a blank file called art.js because that's what we're creating today. And I'm going to start just by requiring the dependencies that I actually need. So in Node.js with JavaScript, instead of maybe doing import, which you could do, I'm just going to be using require, which basically says, hey, I've installed these libraries and I actually want to start using them, so I can then assign them to variables. So I think the first thing I want is johhny-five. So I'm just going to call that 5 for short, just because it's quicker to type. And then I'm just going to require that, and it should be smart enough to figure that out because Visual Studio Code is kind of amazing. So that's me actually requiring johhny-five and saying that that library from now on, when I want to access it, is called 5. The next thing I want is the actual OLED library, and because that's a class, I'm going to capitalize it, and let's see if it's smart enough to figure this one out. It didn't. Oh, there we go. So now that we have them, we can actually start working with them. So before we do anything with this OLED screen, we want to just test that johhny-five is working and is able to talk to the device, right? So we can do like a hello world with it, but I kind of wanted to first describe on the whiteboard kind of how johhny-five actually talks to the Arduino before we actually start on that. So let's go do that. Okay, so we've got our computer right here, and this is kind of the confusing thing for some people to understand exactly how johhny-five works. So I'm going to draw a really bad keyboard here, but you get the idea. And then this computer is like, okay, well, I want to talk to this Arduino, right? So we can have back and forward communication with it. So let's just say that this is the Arduino. Everything has a smiley face too. So this is the Arduino. So what's actually happening when we run johhny-five is that every time we start that Node.js process, it actually uses this really cool library called serial port to establish like a two-way connection between the Arduino and the device, the laptop itself. And what it actually speaks is called the Fermata protocol, which I don't know if you've heard of before, Dan.
I have.
Yeah.
Yes.
So have you used this before?
I think I went to a workshop once where somebody was teaching with Fermata.
Mm-hmm.
I know that students sometimes here use it, but mostly the students at ITP use like the Arduino sort of directly.
Okay, that makes sense. Yeah, and so if you wanted to use the Arduino directly, this particular Arduino we're using today only sort of understands C++. So that's why we sort of wanted to start with something a bit higher level, and it's a little bit easier to sort of stay on your machine.
So if you're using Fermata, you can write the Arduino code basically in JavaScript?
Yeah, so you can write sort of like, you can basically become the remote control for the Arduino through the Fermata protocol. So we have like our JavaScript, which understands the Fermata protocol. And then we have a C++ script running on this board here, which understands the Fermata protocol too.
And that's like an out-of-the-box thing you download and run on the Arduino.
Exactly. So I'm going to actually run that on my, I'm going to run like a very quick script to install that on my Arduinos. And I'm going to show you how to do that so that you don't even have to download the Arduino IDE or anything. So we can do that. And the way that these talk to each other is because they know the same language, which is Fermata, they just kind of send opcodes between each other. So that's not even a 0. So, you know, maybe 0FF, or just that's like a byte that is value like 255. Maybe that means something very like substantial in the Fermata protocol. Maybe it means, hey, start sending power to this pin so that you can turn an LED on or something like that. I don't actually have the Fermata protocol memorized, but I do know that it is based on the MIDI protocol. So it uses like I guess the notes and everything, which is, I think, a really, really cool part of like Fermata's history is that it uses MIDI to do it. So that's like a super high level view of how it actually does it, just because the stuff that we're working with today is so heavily abstracted. So we want to just make sure that you still understand that there's this walkie-talkie thing happening, and that the JavaScript never actually goes and lives on this device. It's just really just a remote control. So, and we're going to have a whole different protocol talking to the actual screen, which I'll draw here later on as well. Cool? All right, let's do it. Okay, so now that we've got our dependencies, we actually want to make sure that it's talking to the device. Now, I mentioned before that the Arduino needs to actually know what the Fermata protocol is, right? So we actually have like a pre-made sketch that Arduino itself publishes with the IDE, and it's called Standard Fermata, and so we want to use that. But having to open the Arduino IDE and then flash a script to the Arduino and then close it again is sort of just annoying, because that's the only thing you use it for. So I ended up making a package, and it's called Fermata Putty. And I think I installed this on Dan's machine. I did. So what Fermata Putty does is it allows you to have a party with Fermata by just being able to transfer the Fermata script onto the Arduino device that you actually have. So that's literally all it does, but it does actually get you started and up and running really quickly. So it's just a command line up that I wrote in Node.js. So we can run Fermata Putty, and then we're going to write the name of the Arduino board that it's actually supposed to be flashing so that it knows what to look for that's plugged in. So we're going to run Fermata Putty Uno. Literally all that does is it takes the Fermata C++ script that the Arduino needs to run, and it just uploads it. And then we don't actually upload any scripts to the Arduino after this. We're just running JavaScript on the laptop, as we said, to just kind of send stuff to that Fermata script that's running. And it's really just sending commands. It's not actually sending any code or anything like that. So hopefully that actually works. It seemed to have worked. I think that I need to do -v just to see if it did. Oh wait, no. Maybe it's debug. Anyway, I can see that it's actually working. So maybe it is --debug. Let's see. There we go. Just so you can actually see what it's doing. So it says found Uno on port blah. It connected. The reset was complete. It's flashing the code, and then we have a nice green status saying that it's successfully completed. So now that we have Fermata running on the device, it's actually ready to start listening for any commands that come in via that USB connection. So now that we have a 5 instance, we want to create a board, right? So we want to create this board instance so then we can start kind of sending stuff to the board and receiving stuff from the board. So I think we just need to do a new 5.board, I think. Wow, this autocomplete is blowing my mind. I don't use Visual Studio Code very often, but it is like super nice. Okay, so we have a new board. What that actually does is it just goes and like looks at all the serial ports or the USB, I guess, ports on your computer, and it goes, are you an Arduino? Are you an Arduino? Are you an Arduino? So it's actually really awesome because it takes a lot of that stuff out of your responsibility to do. So then the board comes back as an object that you can listen to events on. Again, this is very similar to jQuery. So normally where you would have like document.ready or document.onReady, you can actually do like board.onReady, which is actually pretty chill. So I feel like, Dan, you could totally do this.
So far, I'm following everything so far.
Okay, cool. So now that we have we've sort of attached a listener to the ready event, which basically says that we've been able to guarantee that there's a good connection happening with the Arduino. We just want to console log out that it's actually ready. So we can just write yay, I guess, and then let's try and run this just before we sort of get ahead of ourselves and start writing extra stuff. So I'm going to do node, I think art.js, and let's see what happens. All right, seems to have found it. And then we got yay. So that's pretty cool. What johhny-five does too is it actually gives you a REPL, which is I think a read, evaluate, print loop, which is really cool because you can actually start looking at anything that you create globally to be accessible in the REPL. So we're not really going to use that today, but I just wanted to say that it's a really nice feature. So by me writing this, that's actually the instance of the board. So you can see a whole bunch of stuff comes out if you wanted to inspect that further. So to exit, I'm just going to send like the Control-C, just the SIGINT twice, and then, or the interrupt. I forget which one it is, but yeah, so we're going to do that. So we want to actually start using the screen now because that's really the only thing that we're going to do with like using johhny-five is to be able to use it to speak with the screen directly. So we kind of have to go over a little bit of theory of what we're doing today, but we also want to plug in the screen as well. So I think we're actually going to start with the theory first. All right, so we have this here, but I sort of wanted to just start like a new section over here just for now. So we wanted to create this generative tile effect. So we want to sort of explain that first. So let's imagine that our screen is here, our little tiny OLED screen. And the maze before looked really complicated if you're sort of not able to break it up with your eyes. But what it really is it's just a grid. So this is what we're going to be programming today. And this is not actually to scale of what the screen actually is, but it's just giving you an example of like a really small cutaway of the screen that we're going to be doing. So in order to create this generative art pattern, we actually are just going to draw one of two things. So we're going to generate a random number, and then depending on whether the number is more than 0.5 or not, we're going to draw a line that's facing like either, it's either pointing one way or it's pointing the other. So we have like one of two lines. So it's going to be either this line or it's going to be this line. That's it. So it's either going to be leaning forward or it's going to be leaning back. So for example, if I was to use my own brain to do this, which is actually harder than it looks, we can just start sort of generating these lines. But if we let the computer do it instead, it's going to be a lot quicker and we might actually get some really nice effects out of it. So that's sort of how that algorithm actually works. We just split the screen up into tiles, and then we just figure out how to actually draw those lines by cutting up the screen into pieces. So hopefully that made sense. Cool. So the actual screen itself that we're using is, the dimensions are 128 by 64. So I want you to remember those dimensions because they're like super, super important. And I was going to explain how the screen actually works, but I might just leave that till the end if anyone's got questions about it. But because I did write the actual screen library, I can actually explain to you how it actually is able to take pixel data and stuff like that, but for today, maybe we'll just keep going with that. Cool, so the screen actually speaks a protocol called I2C, or it's actually, I think, technically I squared C, but I always call it I2C because that's just like how I read it. But it stands for, I think, integrated communication. I think Scanlime's going to know the answer to this. So it's a way of communicating, and it's actually a really, really cool protocol because it's very efficient. It doesn't take a lot of wires, and you get a lot of control over things like the clock speed and things like that. So I'll try not to get too deep in the weeds, but it's really cool to kind of know how these devices actually work. So generally you have two different devices, right? So I'm just trying to make sure that you can actually all see this and I'm not going off the edge of the screen. But we have our Arduino here. Now our Arduino is known as the master, and then we have our screen.
Sorry, integrated circuit bus.
Thank you. I always think it's connection instead of circuit bus, but yeah, so integrated circuit bus, which is really cool. So we have our Arduino and we have our screen. So the Arduino is known in this I2C or I2C relationship as the master, and then the screen is known in this relationship as the slave. Now, I don't really like the whole master-slave kind of like metaphor, so I like to call this Arduino the captain, and the screen is the sailor. So we're going to go with them today because I think it's a really cute metaphor. So the captain is responsible for, like, you know, sending out commands to like the crew on the ship, right? And the sailor always takes that direction. So generally the captain is controlling the whole scenario and the sailor is just kind of like carrying out those commands. So that's like the best way to think of it. And so in I2C we have our regular power and ground, but we also have like two other connections. So this is getting a little bit small, but one is the clock and the other one is just like the data line. So we have only one line that we need to use in order to send the beeps and boops back. And by the beeps and boops, I guess I mean the zeros and the ones. And then the clock is an external kind of wire as well, because then we can actually, without getting too much into like how this stuff works, we can use the clock externally to actually specify the speed at which we want everything to run. So I2C is actually a really cool protocol. If you want to read more about it, you can definitely look on sites like SparkFun and other sites because it's super, super cool. So that's what we're going to be using today in order for our Arduino to actually like talk to that screen. So you don't see a lot of that when I'm actually coding because I've heavily abstracted that, but that's sort of the gist of what's going on today. So I guess that's what we're going to do. So let's get going.
I think there was a question that I noted at one point, which was, I don't, you know, this might have been from a little while ago, so apologies if this messes up the momentum. But so how much space? Well, actually, I think I might know the answer to this question now. Actually, I'm realizing. But how much space does Fermata and all these JS libraries take up on the Arduino? Is that a concern to keep in mind?
Yeah, that's a really good question. So I know that the standard Fermata C++ script for the Arduino is a pretty big one. Whenever new features want to be added to Fermata, sometimes you have to take other features away. So that's why we have standard Fermata, and then sometimes we have other versions that have like extra things put in there. So this is an Arduino Uno, so it has 328 bytes or kilobytes of memory, so there's not a lot on there, and so it does kind of mean that, 32 kilobytes, I believe. Yes, so it's got 32 kilobytes, and that means that you don't have a lot of room. The good news is that the JavaScript that we're running never actually ends up on the device, so if the Fermata script that we flashed before successfully flashed to the device, then we know it's going to fit. Obviously, that matters when it comes to things like if you have variables or it's trying to buffer a lot of the messages coming through on the device, you might actually see those difficulties as well. So when you're running a program, you also want to leave enough room or have enough good data structures in order to deal with the fact that there are a lot of messages coming through that the device has to hold on to for a little bit. So as usual with everything, it's always balanced. But that's a really good question. And just to remind you, the JavaScript never actually goes to the device. The JavaScript is simply just controlling the device instead. So the JavaScript is just sending opcodes to the device so that we don't have to worry about that huge overhead of how big JavaScript would be to send to it. Cool. So the next thing we want to do actually is to plug the OLED screen in and start interacting with it. So if I have the overhead camera, We have a bunch of different wires. So actually, let's go back and look at the documentation for OLED.js. So I tried to document this as good as possible, but I'm always looking for pull requests or issues if you find anything confusing. So the SDL that's mentioned just over here, that's actually the data line, and then you've got SCL, which is the clock line. So I've been pretty clear about if you're using an Arduino Uno, then these are the pins to use for each. The reset has to go to 4, and then you've got your standard power and ground, which I usually don't document just because it's pretty easy to do a 1-for-1 with those. So I will actually show that being plugged in before we actually get started. So I have my Arduino here, and I have power, ground, reset, clock, and data line. So that ends up being a total of 5 different cables, but it is actually still pretty efficient. It is still, I think, less cables than SPI, and that's just because the reset line is actually...
So I hate to pause you, but
go for it.
I think I'm getting the message that maybe we could focus this camera a little better.
Okay. So this is kind of, the reset wire is not joined to the others, so it's usually the easiest one for me to connect first. So it says in the documentation that reset has to go to pin 4 on the Arduino. So you might not be able to actually see this, but there is a little tiny 4 numeral next to that little pin input. And so I'm literally just trying to connect each one to the correct one as listed in my documentation. So I like to use red for power and black for ground. So I'm going to go ahead and plug them in because they're always like super easy, especially if you've done this a couple of times before. So I just plugged them into ground and power, and that just leaves our clock and our data line. So our data line is actually the brown cable, our clock is the white. Again, you can make up whatever convention you want, but I like to use white for clock because it's just like my own little personal thing that I'll always remember. So the clock, I believe, needs to be pin A5, which is an analog pin. And then A4 is the data line. So the reason why we use A4 and A5 is because most Arduino boards come with I2C capabilities built in, but they use very specific pins to do that. So for an Arduino Uno, the A4 and A5 pins are your clock and data lines for this particular board. So it's not sort of arbitrary. This is kind of how the Arduino board has been set up. The reset pin was just an arbitrary choice by me. So we have a lot of this code here already. We just need to write these middle bits here. And so we have to pass some options in to tell it what size screen we have. We have to give it the address of the device itself, which can vary per screen. And then we also have to create a new instance of our OLED screen. So we're just going to go ahead and do that in the code now in order to sort of start connecting to it.
You're still, in the overhead camera.
No,
yeah.
Thank you. So I'm going to show you that again. So it's just these lines here. We're just going to be doing something very similar to this, but I'm just going to walk you through it instead of copying and pasting. So let's create some options. And by the way, this is old documentation that's not using the most modern JavaScript. So we're still sort of using var and things like that. It's up to you if you want to pull request that. I sort of have just left it old so that people don't necessarily have to use transpilers to be able to use those new features. But it depends on what version of Node they're using. I think most people are on version 4 at least now, so that's good. Okay, so I need to pass in options so that my screen library kind of knows how to control this device. So before I actually put that in, I'm going to establish just some constant variables that are not going to change. So I'm going to call that width. So the width is going to be 128 pixels, and the height is going, is going to be 64. Yes, that's right. So going to be divisible by 8. So that's going to be the size of the screen. I also want to establish something just ahead of time called the tile size, and that's just because we want to be able to change this and have the algorithm kind of automatically adjust itself based on how big or small we want those tiles. So we're going to start with a tile size of 4, and we're going to see how we go, and then I can change that to let you know how that works later on. I keep trying to do my Vim shortcuts. it's like a, what's it called? Like a muscle memory. Okay, so now we can actually set the width to be width, and a shorthand of doing that in more modern JavaScript is just to list these. And then we need the address. So I know for a fact that the address of this particular board is 3D. You can think of an address as an I2C device's like phone number. So you can have multiple I2C devices connected to those analog pins. And if they all have different phone numbers, it's not always the case. Sometimes it's annoyingly not that case. But you can have like, let's say 5 different screens connected. And if they all have a different address or phone number, you can actually kind of control them all without having to kind of like pull wires out and swap them around and stuff like that. So just think of the address as us kind of like being very specific about which device we want to speak to that's connected to that I2C bus. So now that we have the address, and I don't know why, but I'm a semicolon person, so I'm going to put some semicolons in. Once we have the options and we've said sort of, this is the minimum set of kind of properties you need to give to get this going, we're going to create a new variable, and let's call it screen, because that's actually easier to kind of reason about than OLED. We're going to create a new OLED screen. I think that's what I called my dependency. Yes. And let's pass in the options. Cool. I kind of want to run that just to make sure I haven't completely screwed something up. Okay, cool. So it couldn't get the height, and I actually know why that is. So I'm not actually using my library properly. So we do actually need to pass in a couple of other arguments. We need to pass in our board and our 5 instances. Because this is a separate thing to johhny-five, we actually need to be able to give it those things so it can actually use johhny-five to communicate. So we're going to go back to the code and we will pass that in. So I think it was board and then 5. I hope that's right, but we'll just guess. There's nothing like reading your own documentation. All right. So I'm glad I tested that because it definitely blew up. It looks like this is okay. So I'm just going to stop this process and then we'll keep going. So we definitely want to make sure first that the screen's working, but then we want to clear the screen, because sometimes when you start this screen up, it can have sort of some snow on it, kind of like an old school analog TV. I guess you still get snow, just digital snow now on digital TVs. So one of the first commands that I want to show you for this is screen.clearDisplay. And then we can call screen.update just to make sure that that actually gets sent to the device. So now if we run this, let's see if we can cross to the camera. So all I'm really doing is running the same file, but if we look at the camera, you might be able to see there's a little bit of snow on there right now. You can sort of see that it at least did a thing, and then it's very, very subtle. We might actually have to turn
I'm trying to think.
One of the lights out.
Let's take a minute here to see if we can make this a little better.
Yeah. Let me put something on the screen, because that was going to be my next thing anyway.
Put something on the screen.
Screen.drawLine. I'm going to do 0, 0. This is a spoiler alert.
Let people see it.
60. Yeah, and then, I don't know, 12. Okay. There. So it's starting at 0, 0, and then it's going across a little bit and down a little bit. So the one here is just what color I actually want to do. And by color, I mean the pixel's either on, it's like shining in a white sort of color, or it's just off. So you can actually draw with like negative color, and you can just clear out parts of the pixels, which is kind of cool. So just remember that one just always means the pixel is on. So I do actually want to change this library quite a bit because I did write it a few years ago. I would love to have an enum, so it would be something like colors.white or something, or color.on, or pixel.on, pixel.off, or something like that. I think that would be a lot more effective, but I'm interested to hear people's thoughts. Again, raise an issue if you think that you have an idea on that. Another thing that I can do is I can basically tell it not to update the screen immediately. So we can do a lot of like manipulations first and then update the screen all at once. We're probably going to do that today because there's no point in drawing each line individually and kind of bottlenecking the USB connection. I can show you that method as well. I think draw line. Yep, draws a 1 pixel wide line. And yeah, you can say whether or not the screen immediately updates with the result. So cool. So this is literally all we need in our repertoire today in order to start doing this generative art. So everything else is kind of more like the algorithm, but this is definitely like the fastest way to get started with drawing on an OLED screen. So I'll just show you that one more time. There's the line there. So we're just going to be drawing lines in different patterns across like invisible tiles on this screen. Cool. So we have our tile size and we have our width and height. So we're going to be making heavy use of these. We're going to be creating just a couple of helper functions as well in order to kind of start drawing this. So the first function I want is to create a vector, because we want a lot of things where we're dealing with XY coordinates, and you don't really get that in JavaScript. I know that in like processing and things like that, you get these really nice like classes, right, like vectors, but we don't get that in JavaScript. So I'm not even going to pass in any arguments to set the x and y. I'm literally just going to return an object that has the x and the y set as 0. Like, I'm just going to go super simple today. I know this is not necessarily how you would always do it, but this is definitely going to suffice just so that we don't lose time on creating this very fancy, like very correct vector. So now we can actually just get these objects that we can get the x and y values out of. So a vector is really just trying to denote like a point on the screen itself. The next thing we want is to create a tile. So we need to be able to actually draw like either a forward line or a leaning back line. So that's the next thing that we're going to do as well. So I think we might write this first, I guess. We're going to have another function that does a bunch of loops as well to draw the tiles. So maybe we can just do create art, because that's what we're actually going to create. So these are just my placeholder functions, and then we can actually get started writing them. So as you saw on the whiteboard, all we really want to do is just kind of split up each screen into tiles and then just either generate a random number, and based on that, we're either going to do like the leaning line or the falling back line. So maybe we could just write the function to create the tile. So what do we need to do with this? We need to have a random number, right? So I'm just going to call it num. And then in JavaScript, I think we can just do math.random. And we're just going to take like the math.random number, because we can use this pretty easily. So we need to kind of now create one of two conditions, right? So we can just create our empty conditions at this point. So I'm just really saying if num is greater than 0.5, we want to do a thing. Otherwise, we want to do another thing, right? So let's just set up this rule. It's going to be super arbitrary because it doesn't really matter which one you start with. Maybe this one is leaning. Let's do leaning forward, because that's a little easier to do for the first time. And then this else statement is going to be falling back. I guess that's the easiest way to do it. Like, how do you describe this, Dan, normally? Like leaning forward, fully back?
I don't know. I think forward slash and backslash.
Forward slash and backslash.
Yeah.
Wow. That's actually really simple. Thank you.
Because that's what it originally was. So on the Commodore 64,
like on the Commodore 64.
Just printing those characters, forward slash.
Of course, that's so smart. So my first computer was a Commodore 64. So this is making me feel super nostalgic. All right. So what we want to do is we want to establish like two vectors, right? We want to have like the start of the line, an x and y, and then the end of the line, an x and y. So I'm going to create some new variables. So we're going to have line start. Let's call it line start. I don't know what I'm doing. Okay, line start equals, and then we're just going to create a new vector. So we're going to just like manipulate the x and y afterwards. So now I just need an end line. Wait, line start. Oh, I'm getting so confused. Okay, line end. So we should have just copy pasted this line, but it's cool. It's good to type stuff so you remember it. Okay, so now we just need to basically say, you know, like we can set these new values depending on like, you know, what the random number was, and then we're going to actually draw the line. So I just realized that I'll actually need an argument in here. So we're going to need to pass in the screen instance so that we can actually like call a method on it. So you'll see why we need that later on, but I'm just going to do it so I don't forget. Okay, so if the number is more than 0.5, we want to lean forward. So that means that our tile size is going to need to kind of come into play with this. So I think we actually need some more variables to pass in because the tile needs to know exactly what tile it's actually on. So I'm going to pass in a tile vector. So we're actually going to make use of vectors later on as well. Now we can do something like just pretend that that vector exists. We can have tile.x and tile.y. And I want you to think of the tile x and tile y as like the top left corner of that tile where it starts. So that kind of gives us our anchorage, and from there we can start generating lines. This is probably not the correct way to do it as in the book, but this is sort of how I'm going to figure it out. So I'm interested to hear in how you do it, but this is how I'm going to do it. Okay, so if we have our line start and our line end vectors, we have our tile start. This is where we want to sort of start doing it. So we want to maybe set up our line start first. So our line start x coordinate, if it's leaning forward, then it's going to be like right, in the corner, right? So I don't know how else to explain that, but it's going to be right at the start because the forward slash is sort of like, yeah, the horizontal starts that way. So if you have a look at it this way, you can kind of see that it's starting right in the corner. So we can just set that to be the tile.x because that's the starting point of the tile. Then we want line start .y. Okay, so this one is different this time because it's not the y right at the top, it's actually the y right at the bottom. So we're going to do tile.y, but then we're going to add the size of the tile. So if the tile is a square, then we're going to add the tile size. So we're going to do tile size. And then because the x and the y of the tile, because it actually denotes the start of the tile, it's actually inclusive. So I think we also need to take one away just to balance that. But we'll see if that's correct, because I did this like weeks ago in Australia after I saw Tim Holman's talk. So we're just going to make this up. Okay, so now we need to do the line end coordinates. So the line end is going to be like right towards the end of the actual tile itself because it's leaning forward. So we can just do tile.x, and then we're going to plus the tile size, I guess. And then we're going to do -1 as well because it's inclusive. Stop me if this is wrong, because I trust you, Dan. You're much better at this stuff than I am. And then the line end is just going to be, I think it's just going to be the tile.y because it's sort of like ending at the top of the y, I guess. What am I doing? Line end equals tile.y. That should be it.
Yes.
Okay. I'm hearing encouraging things from Dan right now. Okay, so that's the leaning forward. So let's do the leaning back. So the line start .x. So because let's actually just like draw a little one here so that we can actually kind of reference it. So the line start x it's still starting right at the start of the tile again. So I feel like we can just do this. I feel like the tile x, the line start x is always like there. So we can like draw the line like from bottom up, but we're just going to do the line from the top down, I guess. So there are different ways to do this because you can draw the line in backwards orders, I guess. Okay, so the line start.y is going to be just the tile.y, right? Because it's right at the top. So line end.x. Okay, so if the line ends like right at the far part because it's leaning back, it's going to be tile.x plus the tile size. I feel like I'm just writing exactly the same code as the other one.
It should be tile x plus tile size -1, right? Because you're starting.
Yeah, that's how I feel. I just feel like it just feels so repetitive, but there are super subtle differences with it.
Oh, sorry, I'm behind. Like what I'm seeing.
Okay.
What I'm seeing.
Oops.
Because this is falling back.
Yeah, it's falling back.
Right.
Yeah, that's what I thought.
Right.
Okay. Yeah, this stuff melts my brain.
I
This
don't
is
know.
why I can't do it. Like, It's so funny because hardware is like safe and comforting to me, and like this stuff is really scary because it's so much math, and I'm really bad actually at spatial math. Like I just don't have a lot of good spatial awareness in my brain in general. It's just not how my brain thinks. So I really have to put in a lot of effort for this. Okay, so it's going to be at the bottom, so we need to plus the tile size again. -1 inclusive. So, and then this is -1.
Yes. Yep, that's right.
Okay. Okay, so now that we have that, it's the biggest anticlimax ever. It's just going to be line start. I never do autocomplete because I'm not used to having it in Vim. Line start y, right? And then it's going to be line, this is going to go on another line. Line end x, and then line end y, and then the color is 1, and then we don't want it to automatically update because we're going to be like drawing so many lines. We don't want to just like hit this device, and sometimes it can actually overwhelm the devices. And it doesn't break the device, but it does kind of just like bottleneck it, and then sometimes the messages just don't get through. So that's a limitation of like using this way of doing things. If you did this directly on the device in C++, you wouldn't actually see that issue. Okay, so that's a tile. Can we draw the tiles real quick so that this stream doesn't go forever? Okay, cool. So we want to create the art. Again, this is a function outside of our screen. So we're going to just pass in screen, not scream. Okay. Okay, so this is where we do our classic generative art like algorithm, which is a nested for loop, right? So we're going to do let I equals 0, and then I is less than the width of the screen, and then I is going to be plus equals to the tile size, right? So it's going to like jump in tile widths. Hopefully that makes sense. And again, Dan will stop me if I'm going completely off the rails.
I'm 20 seconds behind.
Okay.
I'm listening to your audio. I'm seeing the screen here.
Okay, so this is going to look super similar. It's just like j is less than the height because now we're going to go like tile downwards. So then we're going to do j plus equals the tile size again, right? So we're really just like staggering this thing, so it just can do all the tiles, stop when it gets to the end of the width, and then like do the height, and then do the next row, I guess. So it's doing it kind of row by row, I guess, sort of. No, wait. Yes, it is. Okay. Okay, so now I think we can just call, oh, we need new vectors. So we need to like generate what the tile start and end is, right? Oops. So I'm going to do tile equals new vector. I feel like this has now become a speed code. Tile dot x is equal to I, and then tile dot. So you can see that if I actually had a proper vector function, I could just pass in the xy. So I realized that that was like something that wasn't so great when I created it, but this is still pretty easy to actually fix. So tile dot x equals I. Tile dot y equals j. Now we just need to create a tile, and then we pass in, what did we need? We needed tile and screen. Oh, that's it. Okay, that's easy. Okay, so we create the tile, we pass in our tile object, and then we pass in the screen instance just so we can actually call things on it. I think is that it? That's it. So after we've created the art, we need to update the screen now, right? So like we've sort of like manipulated the screen's buffer. That's sort of what's happening under the surface. It's like frame of pixels. So now we do screen.update because then we're just manually updating it. Because when we were drawing our lines, we were saying like don't immediately update. So I think that's it. I have no idea what I'm doing, but I think this is coming out all right. Okay, so we need to call these functions, clearly. So I think we can just call them in here. So I'm going to just, oops, I don't know, this is a new keyboard, so I'm still actually figuring out this keyboard too. Oh, it's just create art, right? Can I just create the art? I think I can just create that. Is that it? Yeah. So we wrote a lot of code before we actually ran this. So let's see if that actually runs. So I am just, whoop, let me go. So I'm just doing this. So I might actually just clear the screen. There we go. So I'm just running the same file, and then like, let's see if it actually works. Oh my God. It actually worked the first go. So I'm going to make this bigger because our tile size is really, really tiny.
Cool. I'm sorry, I just want to
come and have a look because like, yeah, that's...
Oh, wow. Oh, you can see it there. It's just doing the scan thing, but I think people can see it.
Okay, so let's just change the tile size real quick.
Size,
yeah, because like, see, Dan, it's not scary at all.
No, I have so many
It's exactly the same code. Yeah. So the tile size, oops. Ooh, what happened there?
I've never seen that happen. I'm trying to get out of the way. Like now I'm over here.
Okay, so let's do a new tile size. So I'm just going to run that again. I'm so excited that it worked. Yeah.
So if you wanted to animate something, you would just. Are you continuously sending the same imagery?
Not right now.
So you could do that though.
So you could put this in a game loop, and you might have a pretty limited frame size, frame rate, just because of this USB bottleneck.
Yeah.
But if you wrote the native C++ with the same kind of like thing, yeah, you could do it.
Because something that's interesting that you can do with the 10 print design is you can just change the probability. So right now it's 50% this way versus that way.
That's cool.
And so we could do it right now, but like you could actually, since this is all JavaScript and connected, you could actually make an interface. So you're like altering the probability in real time.
That's so cool.
So like even like right now, if you just go to, I'm standing in the way, unfortunately.
No, you're fine, you're fine.
But if you go to where it's nums greater than 0.5,
yeah,
come over here.
Yeah. So if you just change that to like
0.2 or something.
Oh, I'm so excited. Okay. See, this is where I'm like, no idea what I'm doing.
I have to come over and look.
So does that mean it'll have more forward ones?
Yeah, see?
Ah.
So it has a particular quality in that it's much rarer for it to go the other way.
Today I learned.
Yeah. So one question that I have, so it to me was interesting to watch this because I'm so used to doing the programming to like generate a design like this, but I'm not used to doing the programming to put the design like this in something that isn't like HTML5 canvas or processing with a higher level API.
Totally.
In theory, though, it would be possible. I don't know whether it would be worth doing this or not, but with a display like this, there's no reason why you couldn't do drawing to like a canvas object with a higher level API and then read the pixels of that canvas one at a time and transfer them here.
So I have this thing that uses Canvas where you can make your own fonts for this screen. And it's actually using Canvas. So this is giving you the preview.
I'm going to come stand over here just to be out of the way of it for right now.
So what this does is you can put in the font that you want to use. You can do like the size. And as you sort of change that, it's changing. And this is literally a canvas. And then you change the threshold for what you want like the kind of smooth stuff to be, right? And then when you're happy with it, it goes through every pixel in the canvas file and it gives you a font file to download.
Oh, wow.
And then that converts it into like a frame buffer JSON file that's compatible with my library. The next thing I want to show is actually really cool. It's way cooler, so I saved it to the end. But my friend Hexcellent, do you know Hexcellent?
I don't know if I do.
She's amazing. She's amazing. Oh, she doesn't have it at quick. So it's called OLED JS Designer. So she took my library.
Oh, wow. This is exactly what I was just talking about.
Yes, and like you're gonna lose it when you see this. It's like a thing where you can draw and you can download the image buffer. So that's like really, really small. You can download the image buffer, but what I did recently that I had on my laptop that I can't show you is I had johhny-five running in the browser and it sent it.
Like with WebSockets? Or?
No, in the browser with web USB.
Oh, I didn't know you could do that.
Well, it's really hacky. It's not actually officially supported because you can't send a SIG into the browser. So you have to like put it in a web worker and then, but you can also do it as a WebSocket. So I could send that to my node process and then update it. So that's what she wanted to eventually do with it. And I've basically been forking this project to my own GitHub and like messing around with it. So I've gotten it working with web USB, with Wi-Fi, via like MQTT and then also with WebSockets.
That is wild.
So I wish I could show you, but Hexalin is awesome because she made this.
Well, the two things. One is you just have to come back and do another tutorial.
That would be great.
Or
I would love to.
If you're doing follow-up with any of this, like coding with it or trying more stuff on your Twitch channel, I can like point people towards that.
Yeah,
We'll
totally.
hopefully. Thanks for watching the edited version of that live stream with noopkat. I hope you enjoyed it. This is just a reminder. Check out this video's description. Go and subscribe to noopkat's Twitch channel. Check out her Twitter at noopkat, or like I've been saying for the last 2 years, noopkat. And thanks for tuning in. I'll see you in a future video. Goodbye.